Hi folks, looking at drawing some different types of graphs today. It's basically the same concept of drawing any type of graph, I guess a straight line graph or a parabola, etc. But these can be slightly more challenging. So we're going to start off by, first of all, looking at an exponential graph. An exponential graph. Now, exponential graphs are in the form of y is equal to a to the power of x, where the x value is the indice, okay? It's the power of. I guess with any graph, I've explained before that if you are unsure about what that graph looks like, then the best thing to always do is to draw your table of values and put more and more values in. For example, I'm going to put -3 all the way up to +3. You can do more if you wish. Okay, you can do less, it's up to you, but obviously if you're unsure of what this graph is going to look like, this is the best way to do it. So the first one is going to be, and I'm going to draw the graph of y is equal to the power of x to start with. Okay, so y equals to the power of x. So how do I draw this graph? Well, simply putting the -3 where the x is, so it's 2 to the -3, which you can either do in your head or do it in the calculator. Either way, it's going to be 1 over 8. The next one's going to be 1 over 4. 1 over 2. Anything to the power of 0 is always equal to 1. That's the one thing that often doesn't change. So it could be, if it's 3 to the power of 0, it's still going to be 1. To the power of 1 is 2. To the power of 2 is 4. 3 to the power of 3 is 8, etc. Okay, so once we've done that, then it's a matter of drawing your axis, okay, for x and y. Noticing for my y value, I've gone down to -3. And up to +3, and my values are going up to about 8 thereabouts. So let's go 1, 2, 3, 4, 5, 6, 7, and 8's up here somewhere like that. Okay, don't have to have all those values on there, just have enough that you've got them. Okay, so let's now put some points on that graph. So I'm going to start with the first one, 0, 1. Okay, that's the very middle one, because that's the one that's going to be always going to be the same. Now you can put these as decimals if you wish to, if you want to be dead accurate, but you know what, don't have to be that accurate. So, because it's sketching. So -1, a half, is going to be approximately about there. -2, a quarter, it's going to be half of that again. Then it's going to be really close. Now remember, because it's exponential, okay, whatever that x value is, now x equals -100, -1,000,000, it will get very, very close to that x-axis of x equals 0, but it won't actually touch. Okay, it won't actually touch. Just going to put the rest of them on there. 2 to the power of 4, so it's 2, 4, and 3, 8. Okay, and what you notice that my exponential is a bit of a curved line that looks like that. Now noticing that it doesn't touch. Okay, it does not touch the x-axis. So that's y equals to the power of x. So once again, if you're unsure about what a particular graph looks like, always put a table of values, or do the table of values in your head when you're looking at it. Okay. Again, this is a sketch, and it doesn't touch there. Now, to finish off, I like to look at the domain and range. Okay, the domain is my x values. Well, it doesn't matter where I go on my x-axis. If I go to 0, I've got a point at 1, 3, I've got a point at 8, -2, I've got a point at -1, so at a positive a half. Okay, so my x values are all real x. Doesn't matter where I put my point on the x-axis, there is a point there. My range, however, this is important, my y values, you'll notice, never get below 0, okay, and they don't actually touch 0. So y must be greater than 0. It cannot equal 0. Okay, it doesn't happen. All right, so you'll see there that my domain is all real x, and my range is y is greater than or equal to 0. So y is greater than 0. Range and domain are very easy to do once you've actually got your graph there. Okay, that's my first graph, which is an exponential. Graph number 2, we're going to look at a cubic graph. Okay, once again, a cubic graph, if we don't know what it looks like, we're going to use a table of values. Cubic graphs are in the form of y is equal to x cubed. Okay, or ax cubed, or ax cubed plus bx squared plus etc. It's all different varieties. I'm just going to look at a main thing. It's got an x cubed in it. Is basically a cubic graph. So let's have a look at drawing the graph of y equals, let's say, let's just do x cubed. Okay, so x and y, I'm going to do -3 to +3 again. And then I can put them in. Again, you might remember what it looks like. Hopefully you might recognize that a cubic looks like this. And generally, if I was sketching it, I'd pretty much do that. But let's be a bit more accurate. Okay, so -3 cubed is -27. -2 cubed, okay, is -8. Then -1, and then 0, then 1, and then 8, and 27. Okay, now I'm going to draw my axis here. Now, to be honest with you, well, I don't want to go all the way up to -27 and down to -27. So I'm going to go -1 and -2. I'm going to go to 1. I'm going to go to 2, and I'm going to go to 8. So 2, 4, 6, 8. -2, -4, -6, -8. Okay. Now I could go up to 27 if I wish. I haven't decided. I've decided not to though. So -2, -8, -1, -1. Well, it should be there, shouldn't it? 0, 0, 1, 1, 2, 8, etc. And you can see that my graph is going to look like this. So it's a really bad sketch. Okay, you get the drift. Okay, so that's my y equals x cubed. Now, once again, my domain in this case is all real x. I can go left and right on my x-axis. There's a point, and my range is all real y. Okay, because again, I can go up and down. There's a point there. So pretty easy one, the cubic graph. Okay, the next one, number 3, however, I'm going to look at the hyperbola, or hyperbola, as some people do pronounce it, funny enough. Okay, so we're going to look at the hyperbola. Now, hyperbola is a different one. It's in the form of often y is equal to a over x. Okay. Well, we're going to look at the graph of y equals 1 over x. So once again, I'll say draw a table of values. If you're unsure about what your graph's going to look like, draw a table of values. You may remember, hopefully, what a hyperbola looks like. In brief, looks like that. Quite strange graph. But if you're not sure, this can help you very quickly. Okay, so if I'm going to put some points here. So we've got 1 over -3, or -1/3, -1/2, -1. Now, the problem with this graph is 1 divided by 0 is undefined, so we don't actually have a value there. It's not possible. 1 over 1 is 1, 1 over 2, 1 over 3. Okay, so let's now sketch our graph. X and y, -1, -2, -3. And I hope your graph's a little bit prettier than mine. And I'm going to go, well, let's go up to 1 and down to -1 here. Okay, so let's put some points. Actually, I'm going to start at -1, 1. So -1, -1. -2, -1/2, -3, -1/3, etc. So you can see it goes in that curved motion there. Same thing here. 1, 1, 2/2, 3/3, etc. Once again, it goes in that curved motion. Now, like our exponential graph, okay, it will never touch 0 on the x-axis. It will never hit the x-axis, which is y equals 0. But likewise, it will never hit the y-axis either. Now, these are actually called asymptotes. Okay, as you may have heard before, an asymptote. Okay, we've got two asymptotes here. Okay, and generally it's a line that you can't have. Now we know that x cannot equal 0. Okay, so that's our line asymptote, x equals 0. But we also know that that y can't equal 0 because you can't put anything here for x to make y 0. So the line y equals 0 is also an asymptote. Okay, and that's, I guess, the line of, I guess you call it line of reflection around that axis. But yeah, it's different. We will be going through a bit more about asymptotes later on. Okay, and that's pretty much how you draw that graph. Now, if I look at my range and domain, or my domain and range, okay, well, my domain, in this case, we know that x can be any value here. There's a value there, value there, value there, value there, value there, value there, no value at 0. So all real x, but x cannot equal 0. Okay, and that can come from there as well. My domain, that's my domain, sorry, is all real x, x cannot equal 0. My range is pretty much identical. As you can see here, my y values, I've got a value, a value, a value, a value, no value. So it's going to be all real y, except y cannot equal 0. Okay, so look, a very brief introduction, well, not introduction, I guess, but just a quick way of how to draw some of the more challenging graphs. A lot of time you'll know what they look like anyway. But hyperbola, we'll be doing a little more work later on, looking at asymptotes, and I guess as well the asymptote of the exponential graph there as well. There are a few things that we'll be looking at with those asymptotes, but basically draw a graph, draw a table of values, or do it in your head, and you're happy days. Okay, hope this made sense, and if it didn't, yeah, ask me for some help.